In this video, we're going to be using division with rational expressions, and we also have a big ol' complex fraction. So division in rational expressions is very similar to multiplication, and I say that because all we do is change our division sign to multiplication, and then we flip the second rational expression, which we would call the reciprocal. So I say it's multiplying by the reciprocal. So as you can see, now we have multiplication, and the second rational expression was flipped. Now we could treat it like multiplication, and when I do multiplication with rational expressions, I always say factor any way you could possibly factor, because usually we could cancel some things out. So in this top part here, the numerator, we could factor out a greatest common factor. That term is going to be a 6x squared, and when we divide it out of this binomial, we're left with an x minus 8. 8 cannot be factored, of course, it's just a constant, so we rewrite it, and I stick with multiplication here, and then I could factor out a greatest common factor from this binomial in the numerator. That greatest common factor is 8, and when I divide it from both of these two terms, I'm left with x plus 3. And then in the bottom I have a trinomial, and we could factor that as well. We get x minus 6 times x minus 8, because a negative 6 times a negative 8 gives us a positive 48, and when we add together a negative 6 and a negative 8, we get a negative 14. So now I have all my factors here, and when we actually multiply, we would multiply the numerator times the other numerator, and the denominator here by the other denominator. So essentially we could just ignore this multiplication and then extend the fraction bar. So now we have this top part all being multiplied together, and then we have 8 times these two binomials. But what can we cancel out? As you can see, we have an 8 on top and on bottom, so that could go away. You also have an x minus 8 on top and on bottom, so that goes away too. Now let's multiply together what we have left over. So this is what we have, and it's clear that I cannot cancel anything on the top part with anything on the bottom part, so we could leave this as our final answer, with the exception that my x value cannot equal a 6, because if we plug that in here, we'd get a 0 in the denominator, which cannot work. Now on to this question, and what we have here is a complex fraction, and all that a complex fraction is a fraction with another fraction in either the numerator or the denominator or both. So whenever I come across a problem like this, I write this fraction horizontally as a new division problem. So here we have it, and whenever we have division, we know that we could change this to multiplication, and we multiply by the reciprocal, which means that we just take the second rational expression here and flip it. So here's what I mean. I rewrote my first rational expression, and then I changed division to multiplication, and then this fraction here, the rational expression, got flipped. That's what we call the reciprocal. So now I could just factor as much as I could factor and see what I could cancel out. So this top binomial could factor. We could take out the GCF. That greatest common factor is 3x, and when I divide it out of this binomial, I'm left with x plus 2. This denominator also has a greatest common factor, which is 5. So when I divide out this 5 from the binomial, I'm left with an x minus 3. In this top part here, I have x squared minus 9, and that's the difference of two squares, because x squared is a perfect square, and then that 9 is a perfect square. So when I take the square root of x squared, I'm left with an x. Take the square root of 9, I'm left with a 3. So then I write one binomial with addition and one with subtraction, just like this. And then in this denominator, I could take out another greatest common factor. That looks like it's going to be a 6x. And when I divide out a 6x from this binomial, I'm left with an x plus 2. So everything is factored. I could just determine what is going to be needed to be canceled out. So as you can see, I have an x plus 2 on top and on bottom. We also have an x minus 3 on top and on bottom. And then here I have 3x and then a 6x, so that x in that term could be canceled out as well. So now I'm going to multiply the two bottom parts, because I have a 5 and a 6, and then combine what I have up on top. So here's what we got: 3 times the quantity of x plus 3 on top, and then 30 on the bottom because we had 5 times 6. So I could reduce 3 over 30. 3 over 30 is the same as, that's going to be 1 over 10, because 3 divided by 3 is 1, and 30 divided by 3 is 10. So now my final rational expression is going to be an x plus 3 on top, and then just a 10 on the bottom, and that's going to be my final rational expression.